welcome to chapter 2. This chapter is going to have us solving equations and inequalities. We're going to look at a few select application problems as well. And when we solve equations, we end up with something known as a solution. And a solution is the set of all numbers. So sometimes it's just a single number, but other times it's an entire group of numbers that makes an equation true. So if we want to determine whether or not something is a solution, the easiest way to do that is to just plug in that number and see if we get a true statement or a false statement. So if I plug 3 in for x right here, I'm going to get 3 plus 5. And then I'm going to plug in 3 for this x as well. And then we see if this turns out to be true or false. So 3 plus 5 is 8. On the right-hand side of the equal, remember we need to multiply before we add. So this is a 9. 9 plus 2 is 11. And 8 and 11 are not the same. And so we would say 3 is not a solution. But if I try -1 here, for the equation on the right, let's plug in -1 for x. So if I multiply, I'm going to get 5 minus 2, which is 3. And on this side, if I just jump all the way down here, 4 adding a -1 also gives us 3. And so we end up with the same number on both sides, basically. And so that is how we determine whether or not something is a solution. I don't always go back and check all of my work. You are free to go and do that if you wish, but you're not going to see me going through that every single problem. But it is a way that you can, I might illustrate it right here, it is a way that you can check and make sure that you've done the math correctly. So now we move into actually solving the equations, and I write out quite a lengthy hint here because we want to think of what the inverse, oftentimes out loud we say opposites, and that's not necessarily true. It is an add and subtract. Multiply and divide are called inverse operations. Squaring and square rooting also are called inverse operations. But the idea is what undoes what is happening to the x. So in our first example A, we see x minus 4. Well, what undoes subtract here is add. And if we do it to the left-hand side of the equal sign, we need to perform the same operation on the right-hand side of the equal sign. So we're going to add 4 to both sides. And then we're going to just simply draw our line. So you see that -4 and a +4, they cancel each other out. And so I'm left just here with plain old x, which is what you want. You want to kind of keep undoing and unwrapping things until you just end up with x by itself on the left. Sometimes it ends up on the right. And 12 plus 4 is 16. And then if you go back and you check, you can plug that 16 in. 16 minus 4. Does that in fact equal 12? And yes, it does. So you know you've done your math correctly. So you can check it. Our next example here on B, I start off with addition. And again, add and subtract are called opposites. So we're going to do the opposite. We're going to subtract 15 from both sides. That leaves us with just x. You can cross that out every time if you wish. You don't have to. 3 subtract 15 is -12. And so that is our final answer. Here's an example of multiply. And so 5 and x are being multiplied by one another. What undoes multiplication? Division. And so when we divide both sides by 5, we end up, that just cancels that out. 5 over itself is just 1. And 20 divided by 5 is 4. Oh, and it looks like, let's see if I can fix this quickly. There we go. That's what that should look like. And then this one is usually a little tricky for students. Remember that the bar of a fraction literally translates to divided by. So this translates to x divided by 10. So the opposite of divide is to multiply. So we're going to multiply both sides by 10. And that cancels that operation out. 10 over 10 is equal to 1. So here x would be negative 80. All right, let's see what's on the next page. There we go. I knew I had some fractions in here somewhere. So fractions, just one specific fraction. This is still considered a one-step equation. We need to divide because right now we have 3 halves multiplied by x. So we need to divide out this 3 halves. So think to chapter 1, how do we divide fractions? We multiply by the reciprocal. So I'm going to put a 2/3 here, literally just flip it upside down, and I'm going to multiply by 2/3 here. And if you want to put a 1 underneath that -12 to help you, that's great. And so then this just crosses each other out, and I'm left with x. And on this side here, you can multiply those two things and then divide by 3, but I see I can cross out that common factor of 3. 3 goes into itself once. 3 divides into -12 -4 times. So -4 times 2 is -8. And that would be the final answer to our question. For F, I have a fraction with the x and then it's equal to another fraction. You can go about this in a couple different ways. You can follow the same method that you did here, where you simply multiply by the reciprocal. And this is that 1 is going to cross out here, that -1, and that 10 will cross out here, so I'm left with just x. And then I can cross out any common factors. For instance, 5 goes into 10 twice. So 6 times 2 is 12, but I do have this -1 right here, so the final answer would be -12. Another option, a lot of times when it's fraction equals fraction with an x, if I write this like this, if you recall from some prior math class, there's a little thing here called cross multiply. Cross multiply is not the same thing as cross cancel. And so I'm going to multiply here, and I'm going to multiply here, and that is going to get rid of that fraction for me in one step. So -1 times 5 is -5. Don't forget the x. And 6 times 10 is 60. And then I just have to undo that multiply by dividing both sides by -5. And you can see you get the same answer. So when it's a fraction equal a fraction, you can either multiply by the reciprocal like I did here, or you can cross multiply it like I did here, and it doesn't matter which way you go about doing it. So if you'd like to pause and try one here, you certainly can. I'm going to go ahead and cross multiply this. And so -4 times -21 is +84 with an x. 7 times 8 is 56. So I'm going to need to divide both sides by 84. The problem with the cross multiplying is that you have to reduce after. So both of these numbers are divisible by 7. 7 goes into 56 8 times. 7 goes into 84 12 times. 8 over 12 can also be reduced one more step. So here you can see potentially you have a little work to do at the end. 4 goes into both of those numbers, so this would be a 2, and this would be a 3, and my final answer is x equals 2/3. All right, I think that's the end of one-step equations, so you can practice a little bit of that, and when you're ready to build, we can go on to section 2.2, where these are going to either have 2 steps or lots of steps. So again, think of that idea of undoing. And usually we undo add and subtract first, and then we are going to undo multiply and divide second. All right, sometimes there are parentheses involved and we need to distribute, so it's very problem dependent. But usually if we get extra terms, think about adding like terms and combining like terms. That is part of that process as well, even if they're on opposite sides of the equal sign. So here, I want to get that 8 over to the other side of the equal sign, so I'm going to do the opposite. I'm going to subtract 8 from both sides, bring down that 3 and that x. 26 subtract 8 leaves 18. And now I'm down to just that final step, undoing multiplication by division. So you're trying to get the term with the x by itself, and x equals 6. If you want to check your work at any time, you can just plug a 6 right back in there for x. For instance, 3 times 6 plus 8. Does that, in fact, equal 26? 3 times 6 is 18. 18 plus 8 is 26. And that's what it should be. And so you know your answer checks out. All right, here's one where the x is kind of in a weird spot, but we have to just get used to that. And so I'm going to get that 36 over to the other side. So I want to get the constants together and the x's together. So I do that subtraction piece first. Don't forget to bring that negative straight down. So I have negative x equals negative 25. So you're dividing now, the only number in front of that x is a negative 1. So you're dividing through by negative 1. Or you can think, gosh, if both sides of my equal sign are negative, then they will both just flip to become positive because they cancel each other out. Example C. Again, we're going to combine like terms, so we're going to jump that negative 1 over. We're going to do that add and subtract piece first. We get 2/3 x equals negative 12, because that 13 is negative. Now I'm going to flip that fraction. I'm going to write down the reciprocal, so 3/2. And then on this side, I'm going to write down 3/2. This will all cancel into just a 1, so I have x over here. If you want to put that negative 12 over 1, that's great. And then cancel any like terms. So for instance, 2 goes into negative 12, negative 6 times. 3 and 6 have a common factor, but they're both in the numerator, so we can't cancel them out. We need to multiply them. So our final answer here is negative 18. All right, don't look down at the more complicated ones. Just maybe stop the video and try your hand on the try here. We're going to subtract 2. We get 6x equals negative 12. The next thing we're going to do is undo that multiply. And a negative 12 divided by a positive 6 gives us negative 2. And we can go back and check that if you'd like. 6 times negative 2 is negative 12, plus 2 is negative 10, which is what it needs to be right here. And so it checks. All right. Now we immediately kind of move into problems that could have 3 steps, could have 5 steps. It's just very problem dependent. So we're going to look for things like we want to simplify each side of the equal before we start doing what we did with the 2-step. All right, so if I can simplify this piece, or if I can simplify this piece, we want to do all of that stuff before we start jumping over this equal sign. So for instance, 3x plus 4x, I can combine those like terms. And now I have something that looks exactly like the 2-step equations. Add 2 to both sides. We get 7x equals negative 14. And then when I divide both sides by 7, I get x equals negative 2. Here, it looks like I have x's on both sides. It looks like I have constants on both sides. But when you look at each side individually, I can't put those two together. And I can't put those two together. So I'm ready to start gathering my terms on one side of the equal or the other. So I'm going to get this 15 to the right. And that's going to give me, bring down whatever's left, so that negative x comes straight down. This is now gone. 15 take away 15 is 0. Equals negative 8x minus 9. And then here, I am going to add this 8x because I need to do the opposite. And I want to get all of the x's to the left. So now I'm going to jump that over. This is kind of a new step. We've never had an x show up on the right before. So we want to bring it over to the left-hand side of the equal sign. Negative x plus 8 is a 7x. And this is now gone. You don't have to cross it out. I'm just trying to emphasize. And so divide by 7, divide by 7. And occasionally we're just going to get answers that are kind of icky. So minus 9 over 7 is just my final answer. C, here's a first example with a distributive property in it. We see that we have to simplify this to parentheses 4x minus 1. So our goal here is to kind of get this as simple as possible. We want to simplify each side of the equal before we move anything. And so I'm going to multiply this through. I'm going to get 8x minus 2 plus this x comes straight down. Now I can gather my like terms. The sign isn't going to change. I'm still working with the same side of the equal sign. So 8x plus x. We're not changing the sign. That's a big misunderstanding often with students. We're not flipping a thing because we haven't jumped over the equal. Oh, I always forget my back button is covered by the thing that is recording. Well, let me fix this up real quick. All right, so 8x plus x is 9x minus 2 equals 11. And now it should start to look a little more familiar. Add that 2 to both sides. 9x equals 13. Divide by 9, divide by 9. And x equals 13 over 9. As long as your fraction is reduced, an improper fraction is fine with me, unless my math lab requires you to change it to a mixed number. All right, D and E, don't get intimidated. If you even want to, you can cover this up, by scribbling it out, well, or just put your finger over it. Scribbling it out probably isn't going to be a whole lot of help. And just concentrate on the left. And then do the same thing and concentrate only on the right. So we're going to simplify this first. 6x minus 7x is minus 1x plus 5. Over here, the 10 and the 7 are like terms. So I'm going to take care of that next. And now I have an example more like B, where I have x's on both sides and constants on both sides. So you want x's on the left, constants on the right. And order doesn't really matter. You can bring this 4x over first. The opposite of a negative is a positive. So negative 1 and a positive 4 leave 3x. Bring that 5 straight down. Bring the 5 over to the other side. When you jump over that equal sign, that's when you change the signs. And then undo multiply by divide. And we end up with 4. At some point, if you're able to do some of these steps in your head, that's great. As the course moves forward, I won't show every single step either, because we will have those things in place and it just adds a lot of length to problems that will already have multiple steps. So whenever you're ready to start doing that, feel free. Okay, on example E, we've got this negative right here. So we need to distribute, multiply through by a negative 1. So negative 1 times a positive 5 is negative 5x. And a negative times a positive 11 is a negative 11. On this side here, I'm going to multiply through by that 3. So 3 times x is 3x. 3 times negative 2 is negative 6. And then rewrite that negative 1, it just comes straight down. These two pieces are like terms. So I have negative 5x minus 9. These two pieces are like terms. So equals to 3x minus 7. Let's bring that 3x over the equals. That's when we need to do the opposites. So negative 8x minus 9 equals negative 7. Jump the equal again by doing the opposite of negative 9, which is positive 9. So negative 8x equals, that goes away, a 2. Divide by negative 8. Divide by negative 8. And we get x equals, and then this is going to reduce. And I typically like, personally, my personal preference is to have that negative in the numerator. So this will reduce down to minus 1/4. Taking a 2 out of the top and the bottom of the fraction, and then just putting the negative sign up on top. Also in this section, we have to do some special cases here. So this next page has us looking at all sorts of special cases. Our first special case is what happens when we have lots of fractions. Well, in that case, we are going to do something called clearing out the fraction. And in order to do that, we need to multiply each term, literally each term, by our common denominator. We're not trying to add the fractions, we're trying to get rid of the fraction. So I have two examples here to show you. So, and this one is a little bit different. Let's start on number A, letter A. Between 9 and 2, just compare these bottom two numbers. What is the common denominator between 9 and 2? And the answer to that is 18. So I'm going to put a little 18 all three terms. You have to do it to all three pieces, or however many terms there are in your problem. Now, check out what happens. 9 goes into 18, because if I'm multiplying by an 18, then I can cross cancel any factors. 9 divides into 18 2 times. So I have that 2 left, and I have this 4 right here. 2 times 4 is 8x. No more fraction. This 2 divides into this 18, leaving 9. So 9 times that 1 that's right there is a plus 9. Then 7 times 18 is 136. 126. So all three terms get multiplied. But look at what's happened. In the second step, I don't have a fraction anymore. I've cleared the fraction. So now I can just solve as I've been doing. So in one step, I've taken a complicated looking problem and completely gotten rid of the fraction. And so this is going to be 117. What a gross answer. And so x is equal to, there's definitely no common factors there. Let's try it again over here. I only see this fraction here, this 2/5. I would clear this fraction out before I distributed it. So the only thing I need to get rid of is that 5. That is my common denominator. Since I have not multiplied anything yet, this is kind of protected by those parentheses. So I'm going to put a 5 here. And what I do on the left-hand side, I have to do on the right-hand side. So I'm going to multiply by 5 on that side as well. So this is going to clear that out. And I'm going to have this. But I'm not going to have that fraction anymore. And so now when I distribute, I don't have a fraction to distribute. I just distribute that 2. And now I'm going to subtract this 2 to the other side. And I'm going to get negative 4x equals, that's a bad negative right there, negative 22. And I'm going to divide both sides by negative 4. I'm going to run into my next problem here. So divide by negative 4, divide by negative 4. I'm going to end up with negative 22 over negative 4. 2 negatives make a positive, and I can reduce that down. Take a 2 out of the top and the bottom, and my answer is 11/2. You can see quite a few of my examples don't work out nicely, and so I just really want to emphasize that it's not always going to be like an x equals 2 situation. All right. How do I clear out a decimal? Well, in this example here, I have a 2-digit decimal, I have a 1-digit decimal, and I have a 2-digit decimal. So we're going to multiply by a factor of 10. That will clear out that decimal. So if it's a 2-digit decimal, if it's a 1-digit decimal, that number would be 10. If it's a 2-digit decimal, the number would be 100. If we need to move that decimal 3 places, I would multiply through by 1,000. But I have to do the same thing to all 3 terms. So I'm going to choose 100, and I'm going to put a 100 here. I'm going to put a 100 here, and I'm going to put a 100 there. If I multiply 0.02 times 100, the effect will be to move this decimal place 2 times. And so I'll write down 2x, no decimal. If I multiply 1.6 times 100, it's going to move this decimal 2 times. I'm going to need a little placeholder right here, so it's going to be plus 160. And when I multiply this back piece, it moves that twice, and I end up with 345. Subtract the 160, subtract the 160, 2x equals, let's see what we have on this side, 185, I believe. Yes, that will work out. Kind of working without a calculator. I tend to start these videos with a calculator on the other side of the room. All right, divide by 2. Divide by 2. X equals 185 over 2. All right, and now we move into some special cases, and you can see I gave you a fractional one to try because I feel like I assign more fractions than I do decimals in general. And so we do have a few special cases. I gave you one of each type, so you'll see when we get there. So it looks like here on the left-hand side, nothing can be simplified. I'm just going to rewrite that 2x plus 7. On the right-hand side, I'm going to multiply through by that 7. I'm going to get 7x plus 7 minus 5x, 2x plus 7. Now I'm going to add these like terms right here. 7x minus 5x is 2x. I'm going to get all my x's to the left, my numbers to the right. If you notice here, you've got the same thing on the left and the right. Yeah, that's why it's a special case. Because look what happens right here. When I take the x's to the left, 2 subtract 2, I don't have any x's. I just have 7 equals 7. When this statement is true, our solution set is all real numbers. We have an infinite number we have infinite solutions. Oops, wish I could spell. Solutions. You can say all real numbers. We look at one of these sections coming up. Multiple different ways to write out this type of notation. So I just want to point out that it is infinite. Any number you pick would work. All right. Over here, this special case, let's take a look at it. Multiply through by that 3. When we take that 3x to the other side, same thing happens in this case where the 3x minus 3x, the x's drop out. When I bring this negative 5, however, down, I'm left with this sentence right here that is not true. In this case, this was true, so we had infinite solutions. In this case, this is not true. Negative 5 and negative 6 are not the same. So here we have no solutions. No solutions at all, or empty sets. So if you're unfamiliar with that symbol, it's the set that has nothing in it. Empty sets. All right. Our try here, I've been babbling for a while. Our try here is our last example in section 2.2. So if you'd like to pause and try one of these fraction ones, I feel like this is most likely to be one that would come up. Between 3 and 4, our common denominator is 12. So I'm going to put a 12 in all 3 spots. 3 goes into 12 here 4 times. We need to remember to multiply. So 4 times that negative 1 is negative 4x. Plus, we just multiply. There's no fraction there, so just multiply them together, 96. And then here, 4 goes into 12 3 times. So negative 3 times positive 3 is negative 9. And then we just solve as normal. So negative 4x equals negative 105. Divide by negative 4. Divide by negative 4. And x equals a positive 105 over 4, and there are no common factors there. So that concludes both section 2.1 and 2.2. So I hope you have success. Let me know if I can help you on any of the homework. Thanks.